Okay, welcome back. So this is chemistry question 43 from IMAT 2015 past paper. So I'll be answering this question. So the question says pure water self-ionizes. This endothermic reaction is represented by the equation that we're given here, which is a chemical equation. So we see that water, the molecule itself dissociates into ions, which is a hydrogen ion and OH minus hydroxide ion. Oh, so what's most important thing we must know is that the question about here is all about the pure water itself. Okay, so there's no other added substance. It's pure water itself that is ionizing into these ions. Okay, so the basic thing we must know about self-ionization is that self-ionization in this context is like the water itself produces the ions. Okay, so this can be achieved by water either dissociating into these ions directly, or most commonly that water reacts with other water of its own kinds to produce these ions. Okay, so it's like this. Okay, so H₃O reacts with other H₃O, which is the same kinds of its own species. So we know this reaction is reversible because it's not a strong dissociation. Okay, so one of the water molecule must act as either acid or base. So let's say this will act as an acid. So I'm going to write A, and this one is going to act as a B. Okay, so a base. Okay, so this base will get protonated, accepting proton from this water molecule, and so this will leave OH minus plus H₃O plus, so which is hydronium ion, which can also be represented as a hydrogen ion, okay, a proton. Okay, so this is then simplified into this equation, which is H₂O into H plus and OH minus. Okay, so that's the basic thing about self-ionization. So there's no other added molecule, like for example, we're adding a table salt NaCl, so that dissociates into Na plus and Cl minus. So that's not self-ionization. That's just basically an ionization. But here we're focusing on self-ionization. The substance itself produces its own ions. Okay. And most important critical detail we also know is that this is endothermic reaction. So we know, so we must know in endothermic reaction, the delta H is greater than zero, which means it's a positive. The value is going to be positive for the delta H. So it must be greater than zero. And what it means is that this reaction requires energy. So it requires energy to initiate this process of self-ionization. Okay, so now moving on forward. So which of the following statement is true for pure water between temperatures of 0 degrees Celsius and 100 degrees Celsius? Okay, so now the first option we have is the concentrations of H plus and OH minus are equal between this given temperature. So yes, that's true because uh, as we said, pure water with no other added solutes, because this question is all about the pure water self-ionization. Okay, so we know if there's no other added solutes, so surely the concentration of H plus and OH minus is going to be equal and produce at equal moles. So as it's given here, H₂O is giving 1 mole of H plus and 1 mole of OH minus. So hence their concentration is also going to be equal because they're produced at equal moles. Okay. So yes, this statement is easily true. Now the second question we have, the second option we have, an increase in temperature causes the pH to fall. Okay, so now this question is a bit very tricky. This option is a bit very tricky to solve and to decide whether this is true or false, because we would easily assume that water must be neutral, the pH must be 7. But there is a catch behind it because it's increase in temperature and all. Okay, so now to solve this for option 2, we're going to have to consider something. So since we know this reaction is endothermic, so it requires energy to initiate this process. So meaning increase in temperature will favor that endothermic reaction. So temperature increases is going to favor that endothermic reaction. Okay, so increase in temperature favors that. Okay, and the most important thing is that as the endothermic reaction is being favored with increase in temperature, this will force the equilibrium to shift towards the right hand side, okay, towards the reactant H plus and OH minus. And the other most important thing is that this increases the ionization, so to produce more H plus and OH minus, because the moles of H plus and OH minus are produced same, but the pH that we know is dependent on the concentration of the hydrogen. So pH, as we know, is equal to minus log of H plus. Okay, so pH is dependent on the concentration of H plus. So meaning if you have more H plus, more hydrogen ion concentration, the pH will decrease, making it more acidic. So it's not going to be exactly neutral where pH is 7. So we know that as we increase the temperature, will favor endothermic direction where ionization will increase to produce more ions, so H plus and OH minus. But although we know that equal moles are produced, so we might think because H plus is increasing, OH minus is also increasing. So OH minus somehow would cancel out the effect of H plus. But we must know most important thing that pH is highly uh, proportional to the H plus. So I mean that concentration of hydrogen will affect the pH because pH won't really consider OH. Okay, so H plus as they increase, the pH will decrease. Okay, so now I'm going to use some examples so that you can understand much better. So, for example, now at 25 degrees Celsius, this is the normal room temperature. So at 25 degrees Celsius, we know that Kw value, which is the water self-ionization constant, or we can say it water autoionization constant. So we know that Kw most commonly is 1 times 10 to power negative 14 mole square per dm 6. Okay, decimeter power 6. Okay, so in pure water, since we are talking about the pure water, we know that the H plus and OH minus can be represented as value X because we know they're produced at equal moles. Okay, so we know the common general formula for Kw expression is that Kw is equal to H plus and OH minus. Okay, so this is the general expression. So with this general expression, we're going to substitute the value of X into this H plus and OH minus. Okay, so this will give us 1 times 10 to power minus 14 is equal to X times X. Okay, so we have H plus and OH minus. So we multiply together, we get X square. Okay, so 1 times 10 to power minus 14 is equal to X square. So this we will take the square root on the both sides. So this will give us this expression. So then the value of X will be 1 times 10 to power negative 7. So this is the value for X. So now we know since this is the value of X, this is the value of H positive. Okay. The value of H positive and also the value of OH minus. But since we know that we're focusing on pH, that only includes the hydrogen ion concentration, we're going to ignore this hydroxide ion. Okay, so now when we want to calculate the pH, pH is equal to minus log of H plus, which we have the value of H plus, the concentration of hydrogen ions as 1 times 10 raised to power negative 7. concentration. So this will give the pH equal to 7. Okay, so now this is the case for a normal room temperature. Okay, so as we know, the option here explicitly states there's increase in temperature. Okay, so now imagine if we go above this temperature, more than 25 degrees Celsius. So now at temperature that's greater than 25 degrees Celsius. Okay, so we assume that it still stays in a liquid form. It does not evaporate, so we don't have to worry because we're discussing the temperature till 100 degrees Celsius. So we don't have to really waste time thinking about going beyond 100 degrees Celsius. So this is all about being in a liquid form. Okay, so now we know uh, the most important and critical detail that as temperature increases, the Kw is going to also increase because Kw is a equilibrium constant that we must know. So Kw is equilibrium constant, and we know the general rule for almost every equilibrium constant is that they're dependent on the temperature. So meaning as the temperature increases, the Kw value will also increase. So hence initially the value of Kw, which was 1 times 10 to power raised to negative minus 14, approximately we'll say above 25 degrees Celsius, it's going to increase. The Kw value increases. So let's say this increases to 10 raised to negative 13. Okay, so mole, the unit is going to remain same. Okay, so as in pure water, we know that H plus and OH minus concentration are equal. Okay, because they are produced at equal moles. Okay, so we know that. And we know the general expression for Kw is equal to H plus multiplied by OH minus. And we know we set the value of the concentration of this ions as X. So we are going to simply implement into that expression. Okay, so minus 13 because we know at increase in temperature the Kw value increases, so meaning it gets less negative in the power. Okay, so less negative, so the value increases. Okay, so this, and we know if we multiply x and x just as we did over here, it gets x squared. Okay, so now we take square root on the both sides over here. Okay, and so this will give us x is equal to 3.16 times 10 to power minus 7. Okay, so now this is the concentration of H plus and also OH minus. So since we are talking about pH, so we're going to ignore the OH concentration. So we're going to only take an account for H plus. So pH is equal to minus log of 3.16 times 10 to power minus 7. Okay, so this will give us the pH to be approximately equal to 6.5. So now we can see the trend over here that pH decreases. So there's a change in pH as the temperature is being changed. Okay, so as the temperature is being drifted from the normal temperature like 25 degrees Celsius, as we've seen over here, as the temperature increases, the pH will decrease because there's more ionization producing more ions. But I know you're still thinking about the hydroxide ions, but we're going to ignore that because pH focuses on the concentration of hydrogen. So we're going to ignore the OH minus. We're only going to use OH minus when we're dealing with Kw expression. But in pH, we're just dealing with the H plus concentration. So now we can see there's decrease in pH. So pH changes as the temperature increases because we know that Kw, which is used for water autoionization, this is proportional to temperature. So increase in temperature will increase the Kw. Okay, so That's why, yes, so increase in temperature causes the pH to fall, which is true, as we can see from this calculation, which is example. But in IMAT, you don't have to do this long calculation because it's going to be time consuming. But just for example, to show you exactly why the pH changes with increase in temperature. So this is the proof over here. So hence the option 2 is true. Okay, so now moving with option 3, increase in temperature causes uh, an electrical conductivity to decrease. Okay, so this is false because we know that increase in temperature. So I'm going to write here. So for option 3 over here, because we know that as the temperature increases, this will result in increase in ionization. Okay, so this will increase in ionization to produce more moles of ions. So more ions are produced from ionization because if there's more ions, there are more charged particles. So more charged particles will carry the electrical conductivity. So hence, increase in temperature must increase the electrical conductivity. So hence this statement is false. Okay, so increase in temperature must increase the electrical conductivity because there's more charged particles, more ions produced from the water molecule due to increase in temperature, causing it to self-ionize more. Okay, so that's why option 3 is false. So, and yeah, the most important detail about option 2, there's one more. So I'm going to write a very general expression. So that's Kw is proportional to temperature, but this temperature and all is inversely proportional to the pH because pH will decrease if the temperature increases, but if temperature decreases, the pH will increase. Okay, so the pH will increase, and this is inversely proportional to the H plus. But the H plus concentration is proportional directly to temperature and the Kw value. Okay, so this is the general expression you must keep in mind to be able to solve this question very quick without wasting any time in proving and then getting to the right answer. Okay, so these two are only the correct option and the third one is wrong. So hence the only correct option is option D, 1 and 2. Okay, so that's how we solve this question. So thank you guys for watching my video. I hope you find this video helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.